is applied psychology, and I'm now a design engineer in Orient Securities in Shanghai, China. And my recent research fields mainly focus on the application of psychology in design and artificial intelligence. And today, I'd like to talk about our research about application of emotional voice user interface in security industry. This research based on one of our company's application projects. Through the combination of sentiment algorithm and emotional design, the application and prospect of the intelligent service robots in the securities industry were explored. And it is aimed to help the securities business department effectively reach more customers while optimizing the service experience. And I will describe this research in detail from the following 5 aspects. The first is about the background of the voice user interface and our program. Next is about how we combine NLP with psychological methods to enable the robot with the ability of emotional recognition and feedback. Also, we use a comparative experiment to evaluate the effect of the optimization. The results shows that the customer's investment inclination and satisfaction with the robot has been significantly improved. And finally, is about our contributions and the following up directions. Well, and in the era of big data, there are more and more application scenarios of intelligent voice devices. And in recent years, artificial intelligence has become an important way to accelerate the rapid implementation of smart finance. The intelligence transformation of business departments was first applied in banking industry, while its application in the security industry is still in the initial stage. So, last year in 2021, our company introduced the intelligent service robot Nai as a window for the business department to communicate with customers in order to provide customers with business consultation, investment teaching, and finance products introduction, stuff like that. As shown in this figure, now Nai is working in front of our securities department. However, through years taking data tracking, it was found that the intelligent robots lacked some anthropomorphic attributes, which make a customer's combination of it still in a contradictory state of what is a tool or an intelligent service robot. So in order to make customers have more natural and fluent experience in a dialogue, we decided to optimize the system. We know that the emotions generated by customers in the process of interaction will affect their impression and the evaluation of the beverage, and then affect their desires and the feelings of trading. Therefore, emotional experience is an important factor that cannot be ignored in the service industry. So we plan to do some research to make the robot have a consistent personality and speech style and give corresponding feedback to different emotions of customers. Just like Zhang Domain said in emotional design, people can more easily relate to products, services, systems, or experiences at the personal level when connecting with others. So here in the picture of the emotional voice user interface system, through the combination of natural language processing with the theoretical methods of cognitive psychology and personality psychology. A closed loop in national voice user interface system is established. And the main purpose of this system is to build a complete personality system for the robot and optimize the design of dialogue scripts. At the same time, combined with the sentiment text generated by the emotion recognition module and the pre-constructed speech design principles, the emotional responses will be generated after answering the questions by natural language processing technology. The text is converted into human speech by text-to-speech. So that the robot can identify the customer's emotional state and use corresponding speech to answer. So this is the whole working process of the system. So as for the emotional design, it is carried out from three aspects: emotion annotation, emotion recognition, and emotion feedback. The emotion annotation includes includes emotion classification and corpus construction, and the emotion recognition includes emotion algorithm and dialogue system, and emotion feedback includes persona design and dialogue scripts design. So the main contribution of our company are around these three aspects. The first one is a settlement algorithm module of the intelligent robot is constructed, which fills the blank of corpus in the securities industry. And the second one is using the theory of personality psychology. We innovatively put forward the robot emotional system, which endows the robot with more personality attributes. And the third one is the emotional dialogue scripts are designed and applied in the process of emotional feedback to establish the closed loop emotional voice user interface system. How to make robots recognize emotions? The first step is to build up emotion corpus. In order to make the module recognition more suitable for real and abandoned scenarios, two parts of data were selected as training sets for the emotional module. One was taken from the real customers' conversations of the background data, and the other part was the chat data from Weibo, which complemented the richness of answers and module practicals. In the research of settlement algorithms, emotion tagging corpus can be roughly divided into two categories. One is one-dimensional emotion tendency corpus, and the other is multi-dimensional composite emotion corpus. So the intelligence conversations in different scenes meets different users' needs, and the range of emotion recognition is also different. For example, the main function of the chat robot is companion, so it has the most extensive emotion recognition, and the main functions of home robots are linking and manipulating. So there are relatively few requirements for emotion recognition. The emotion conversations of the security business departments are mainly aimed at reducing customers' negative emotions and enhancing their goodwill towards the corporate finance brands. So this survey uses emotional deposition to divide the questions into positive, neutral, and negative labels, so as to construct the emotional corpus. On the one hand, if the customers have negative emotions, the robot needs to appease and guide them in time. On the other hand, if the customers show positive emotions, the robot needs to respond positively to further stimulate their interest. Finally, a corpus containing 100,000 more than these emotional deposition labels was formed for algorithm training of emotion recognition. And as for emotion recognition algorithm, with the help of the pre-training method, emotional recognition has been markedly progressed. However, prior knowledge of emotions such as emotion words and the polarity of emotion words is neglected in most pre-training processes, although in fact they are widely used in traditional emotion recognition methods. So in this emotion recognition algorithm, the sentiment knowledge enhanced pre-training for sentiment analysis, that is SKEP, based on emotion knowledge enhanced is used. Through supervised learning, the emotion prior knowledge is automatically mined, and then the pre-training target is constructed by using the prior knowledge so that the machine can better identify emotions. As shown in this figure, SKEP consists of two parts. Sentiment masking identifies the emotion information of the input sequence based on automatically mined emotional knowledge and generates a masked version of deleting this emotion. And the second one is the sentiment prediction requires a transformer encoder to restore the masked version of its information. Three prediction targets are joint optimized sentiment words prediction, words polarity prediction, and viewport collection prediction. So in this way, by pre-training and the sentiment-orient optimization goal, the automatically mined sentiment knowledge is effectively embedded into the semantic representation of the module, and finally the sentiment oriented semantic presentation is formed. After the SKEP module training is completed, the classification layer is added to the transfer encoder, and the sentiment probability is calculated according to the output semantic presentation, so as to identify the sentiment of the text. Finally, the sentiment algorithm module is invalued, and the accuracy of the data set is as follows: more than 97%, which indicates that the sentiment recognition effect of this module works well. The typical structure of an intelligent dialogue system includes four key components. They are natural language processing, dialogue state tracking, dialogue strategy learning, and natural language generation. And firstly, in the aspects of natural language processing, it pairs and maps the text language input by users to semantic slots, which are predefined according to different signs. The finger shows an example of inputting an English natural language representation of show restaurant in New York tomorrow to the machine, where New York is the location designed as the slot value, and the domain and intention are specified representatively. There are two typical expression types, and one is the discourse level category, such as user's intention and the discourse category. The other is text information extraction, such as named entity identification, slot value filling, and so on. So after recognizing the sediments input by customers, the robot needs to output emotional feedback to form the effective closed loop. First of all, we need to shape the personality of the robot to make it have the same personality to keep a consistent conversation style. Personality is a unique integration module that consists person's thoughts, emotions, and behaviors with uniqueness, stability, and integration. So in the era of psychology, personality can't be directly observed, but it can be inferred from external behavior patterns. The ever-changing behavior and the stable inner quality constitute personality. A robot's personality can be embodied in many ways, such as being seen through visual interaction, being heard through voice interaction, and being felt through gesture interaction. So personality theory can be roughly divided into two categories. Personality typology theory is to divide personality into several types according to a certain standard, and each individual belongs to only one type. On the contrary, the theory of personality traits does not divide personality into absolute types, but holds it that it's composed of many traits as a lasting and stable behavior tendency. So in order to establish an intuitive and abundant personality system for robots, this survey combines Myers-Briggs type indicator and output personality traits theory as the foundation of the personality system. And based on personality theory, combined with a variety of user research methods, a complete personalized design methodology of intelligent robot is established, as shown in this figure. Firstly, the raw elements of robot characters are refined through in-depth interviews and the desktop research. Then, in the form of an intelligent robot persona workshop, 17 experienced designers and algorithm engineers are recruited as experts user representations. Questionnaires, personality tests, and storyboards are used to fill in personality information for the robot, and the conversation scripts are designing. Through algorithm mapping, the problem is combined with emotional conversation packages so that the robot can give corresponding feedback to different emotion to users. And abandoned persona answers the question how to make the robot have an interesting soul. According to the results of the questionnaire, the core personality characteristic of the robot is ESFG, executive. This personality is helpful and responsible, which fits well with the service attributes of the intelligent robot. Then, based on Alpert's personality trait theory, the personality of ESFG was divergent, and the word cloud clustering analysis was used to conclude the treat. And the results show that the cardinal trait of the robot is trustworthy, and the central characteristics include intelligent, efficiency, friendly, initiative, logical, well-mannered, and so on. And people's psychological demands are divided into 5 levels from low to high by psychologist Maslow. That is the physiology, safety, belonging and love, respect and self-realization. The needs of robot can be layered. The basic needs are living habits, and the intermediate demands include hobbies and interpersonal relationships. Finally, all the personality attributes has been summarized, and the personality portrait of the intelligent service robot in the security business department has been established. And like the way of constructing the personification system before the dialogue design, it is necessary to refine the principles first, so as to make dialogue unified and natural. The principles of the voice user interface of smart speakers are regarded as the main reference because of their most extensive interaction scenes with users, such as Google Conversation Design, Amazon Conversation Design, stuff like that. In this study, the Baidu Dual OS system principle was which is most appropriate to this thing of the intelligent service robots in the security business department. So it be selected. This principle gives consideration to both rationality and sensibility in conversations. The rational principle means usefulness in imprehensive, goal-centered, accurate, and cautious, while the perceptual principle is the pleasantness of dialogues in emphasizing natural, friendly, and individuated. And in addition to basic dialogue principles, conversation also need to meet the transformation goals of target business scenarios. So during the question and answer process, robots sometimes can't cover all personalized questions and can't help users to handle business directly. So if the robot can't find the answer, guiding can be used as alternative. So therefore, the guidance principle has been added to the dialogue principle system of intelligent robots in the security business department. Finally, 10 indicators are determined as useful, include accuracy, effectiveness, naturalness, and coherence, and the dimension of pleasantness, dimension of guidance. And these indicators are used as the topic of the evaluation questionnaires for data collecting. And how about the optimization effect? In order to evaluate the effect of settlement algorithm and the dialogue design, besides the accuracy of the algorithm, the optimization effect was also evaluated by comparative experiments. And the promotion scores and significance were calculated. And here is the details about the evaluation experiment, and the results showed that the reliability of the questionnaires was tested and calculated. The Cronbach coefficient was good, and the descriptive statistics, paired sample t-test, and the regression analysis was carried out on the pre-test and post-test data. So as shown in this figure, the investment and the client inclination and satisfaction of customers has been significantly improved. And the dimensions with high scores are friendliness, emotionality, and the coherence. After optimization, the improvements of accuracy, personalization, and naturalness are the highest, which shows that by enriching the dialogue context, the robot has improved the speech strategy for different customers to some extent. So in conclusion, this survey focused on things of security business department and optimize the speech function of the intelligence service robot 9 as the aspects of emotion annotation, emotion recognition, and emotion feedback design so as to enhance the experience value of customers. And the main conclusions of the survey are as follows. How about the future? This research is the preliminary innovative attempt at intelligence service robot in the security industry. So the motion algorithm module in this paper based on SKP module, which can automatically learn the relationship between word meaning and word order with strong generational ability. However, due to the lack of corpus data in a real scene involved in a survey, there is still room for optimization of natural language processing module. Also, in addition, this survey mainly uses language and text information for identification, and the dimension of emotion recognition is efficient. So the hardware upgrade of the robot can collect more extensive environmental information around it. So managing the next step, we know the integration of algorithm and the psychology will also be more and more widely used in human-computer interaction. In this survey, the emotion recognition algorithm is applied to intelligent dialogue system, which helps the dialogue robot to select text and that matches the user's emotional better. So along this line of consideration, we can along this line of consideration, the emotion recognition algorithm can be applied to more things. And yeah, that's all about our introduction of our research. Thank you.
Thank you very much. And does anyone have any question?